Hey there, in this example here, we're going to be looking at identifying amplitude and period of a sine and cosine graph. Now remember, sine and cosine graph, this is a sine graph, this is what it looks like, and then a cos graph, so I'm going to write here sine, where this is the x and this is the y, and then remember the cos graph looks like this, okay? Technically it carries on, there's an infinite amount of revolutions, but we're going to just focus on the one cycle. Okay, so here we go. So that's the sine and cosine. It goes on infinitely, both directions. Okay, so they both go on both directions. But we're going to focus just on the one cycle. So from starting from 0, ending back at 0 again, after a full cycle, it repeats the cycle again. This is called the period, how long it takes before it starts the cycle again. Okay, so period, remember for sine and cosine, the period is given by 2 pi divided by n. Now in class I would have talked about why it's divided by n. It's simply just a dilation factor. And same thing for cos, okay? Whilst the amplitude, on the other hand, amplitude is the height that it reaches from the center of the graph. So when you do this sinusoidal graph, there is a center line. And that center line to the maximum or center line to the minimum is what we call the amplitude. Okay, so the amplitude in this case here, we can see that usually sine has a maximum of 1 and a minimum of 1. That's usually in a unit circle. Sine is the y value, so the maximum y value you can reach is 1 or negative 1. That's why the amplitude, which is only interested, it doesn't matter whether it's down or up, the length of it is 1. So in this case here, okay, amplitude can never be negative. Can never be negative. That's the first thing I want you to think about before you answer any questions, okay? So now, let's answer part A. Part A, you've got the function is equal to 2 times sine of 3t. Now in class I would have talked about this as being a dilation factor from the x-axis, so that means I'm going to change the graph now. So the graph, which used to be a maximum of 1 and a negative 1, what it's doing now is you're doubling the graph, you're stretching it vertically, and you're stretching it vertically down, so the cycle now becomes negative 2 to 2. That's what the amplitude is. So the amplitude is determined by this dilation factor. So I'm going to write here, this is the dilation factor. Okay, so it's a vertical stretch. And clearly the amplitude is 2. The distance is 2. It doesn't matter if it's negative. Even if this is a negative, it doesn't do anything. All it does is a reflection. We're only interested in the amplitude, which is the length. That's another common mistake. So a lot of students think you can have an amplitude that's negative. No, it can never be negative. Yeah. So the amplitude in this case is 2. So I answer the question and say amplitude equals 2. The period, okay, is given by the dilation factor with the x or x-axis. In this case, it's the 3. You're multiplying, it looks like you're multiplying 3 to the t, but actually what's interesting is you're doing a compression. You're not dilating it horizontally, so you're not stretching it horizontally by factors of 3. In fact, when you put a 3 there, you're actually compressing it by a factor of the reciprocal, which is a third. So you actually make it thinner. So that's why it's a third multiplied to what a normal distance, a normal cycle in a unit circle. How long does it take to make one full revolution? Normally 2 pi. That's where the rule comes from, where it's 2 pi on n. See, n is the dilation factor, and that's why it's 2 pi on 3. So that's how long it takes to make one cycle. So essentially to do one nice full cycle, if it's a sine graph, it means that from the distance from here to here is 2 pi on 3. That's how long it takes. Okay, so then you do another cycle, that's another 2 pi on 3. And you do another cycle, that's another 2 pi on 3. That's essentially what a period means. Okay, so that hopefully helps you understand what the question wants you to look at. We now know the period is 2 pi on 3 and the amplitude is 2. So if I answer part B now a bit more quickly, so f of t is equal to negative half of sine of t over 2. You see, when I look at this question, I'm saying it's negative half multiplied to the sine function. right? And remember, the negative doesn't matter. The negative is a reflection. What the dilation factor is half. That's my dilation factor. So what that means is my amplitude, remember it's never negative, my amplitude is half. The negative just swaps the graph. So the graph now, instead of being like this, it now does this. It's a reflection. Okay, so that's what it looks like putting the negative in front of it. So, but the amplitude doesn't change. The amplitude is still half now. Okay, so that's the dilation factor. I've essentially compressed it into half. And then, what's my period? So again, same thing. So let's look at the period. Period, we know the rule is 2 pi on n, but like I described to you, it's based, the n value is a dilation factor. So here you have to see it as it's half times t, right? So instead of half, so in this one it was 3, the reciprocal was 1/3. Then if this is half, the reciprocal is 2. So what you're actually doing now is that you can think of it as it's 2 pi on half, or another way of thinking about it is 2 pi times 2. Okay, and if you figure it in that sense, then it's 4 pi. Or if you want, you can write it as 2 pi divided by half. Do the reciprocal when you're doing division, so it becomes 2 pi times 2/1, and that's how you get 4 pi. Okay, so either way is the same thing, but hopefully you understand that I'm trying to say this is a horizontal dilation or stretch, and this right here is a vertical dilation, which means a vertical stretch. Okay, so this is the dilation. Technically, you should remember there's a 1 here, so it's 1/2. And there you go. So the answer is period is 4 pi. So it means that the graph, for it to make one nice full cycle, it is a distance of 4 pi. The amplitude, on the other hand, is half. Okay, so you can think of it as, traditionally, if it was from 1 to -1, this is what the graph looks like, to 2 pi. What we've done now is we've shortened it to half, to -half. Okay, so the graph is shorter. Notice there's a negative, so it goes down, comes back up, comes back down, right? But we also stretched it horizontally, so now it looks like this. To make one nice full cycle, it has to look something like this in order to reach 4 pi. So the distance is 4 pi, and the height, the amplitude, is only half. That's essentially what you're doing. Okay, hopefully that now kind of makes a bit more sense than what I initially had started off with. And so then finally answer the question, if you're just looking at how to do this question C, we can just go straight to answering it. 4 cos of 3 pi t. So if I were to answer this question straight off the bat, I'll just simply do amplitude is clearly the dilation factor, which is, I'm going to highlight again, it is whatever you multiply into the function, which is 4. So I know amplitude is 4, and then period is equal to 2 pi on n, and n is the dilation factor from the y-axis, which affects the x variable, and we can see it's 3 pi. Okay, so I know a lot of students don't think there's that pi, the pi is included. So you put in 2 pi on n, this is my n value, so n is 3 pi, and so 2 pi on 3 pi, pi divided by pi is 1, and then you end up with 2/3. And that's okay, you don't have to have a pi. It just means that the period now in this particular graph, cost graph, it looks like this, has a maximum height of 4, so it goes up by 4, goes down by 4, so -4 is my minimum. And in order to make one nice cycle, it takes 2/3 the length to get there. Okay, then another 2/3 to get there, another 2/3. Okay, hopefully that helps you understand now how to find amplitude and period, but I hope as I'm explaining it, you have a more of a visual context of what's happening. A lot of students often just look at amplitude and period separately. They don't see it as a graphical sense. I want you to visualize it in a graphical sense. Okay, hopefully that makes a bit more sense for you there, and I'll do more examples in the next videos.